Information on radiation sterilization. What is radiation sterilization? It is the removal of microorganisms from equipment, specifically medical equipment in this case. When is radiation sterilization used? Not all medical equipment is disposable. Some are used repeatedly for different patients. These medical equipment need to be sterilized to prevent diseases from spreading from one patient to another. Two types of radiation used: ionizing radiation and non-ionizing radiation. Ionizing radiation is the use of short wavelength, high frequency radiation to destroy microorganisms. This radiation can come in the form of gamma or X-rays that react with DNA, resulting in a damaged cell. Non-ionizing radiation uses longer wavelength and lower energy. As a result, non-ionizing radiation loses the ability to penetrate substances and can only be used for sterilizing surfaces. The most common form of non-ionizing radiation is ultraviolet light, which is used in a variety of manners throughout history. So how does it work? The radiation causes severe damage to the cell components, specifically the DNA. The radiation has enough energy to ionize atoms and molecules. It can create charged particles and free radicals. These free radicals made inside a cell's nucleus can cause damage to the cell's components and breaks in the DNA structure. If enough damage is done to the cell's DNA, the cell cannot function properly or reproduce, and the result is cell death. So what are the methods used to produce the radiation? Heat, chemical sterilization, and radiation sterilization. In this case, methods of sterilization exist using radiation such as electron beams, X-rays, gamma rays, or subatomic particles. Steps taken to sterilize medical equipment. Radiation is used to sterilize medical instruments by first sealing a clean but not bacteria-free instrument in an airtight bag. The bag and instrument are then placed in a very large field of radiation that can penetrate the bag. These ionizing radiations can kill the bacteria, and the airtight bag will keep the instrument sterile until the bag is opened in the medical facility. So are the equipment radioactive after the treatment? No, they're not. Irradiation with X-rays or gamma rays does not make materials radioactive. Irradiation with particles may make materials radioactive depending on the type of materials and their energy and the type of target material. Neutrons and very high energy particles can make materials radioactive as they have good penetration abilities, whereas lower energy particles cannot make materials radioactive as they have poor penetration abilities. So the advantages is that it doesn't degrade equipment during sterilization. It is used for equipment which gets altered by heat easily, leaves no chemical residue, and is available immediately after sterilization. Why are many of these products unable to be sterilized using steam or heat? Although heating provides the most reliable way to rid objects of all transmissible agents, it is not always appropriate because it will damage heat-sensitive materials such as biological materials, fiber optics, electronics, and many plastics. So there are disadvantages, which is while the use of chemical processes avoids the problem of heat damage, users must ensure that the equipment is compatible with the method being used. Chemical processes pose new challenges for workplace safety. The chemicals used to sterilize equipment makes them harmful to humans. Other applications of this process are used for food. Applying a suitable amount of heat over a suitable period of time slows the decay of foods and various liquids, preserving them for safe consumption for a longer time. In conclusion, sterilization is a term referring to any process that eliminates or kills all forms of microorganisms, including fungi, bacteria, viruses, and spore forms present on a surface, contained in a liquid, in medication, or in a compound. Sterilization can be achieved by applying heat, chemicals, irradiation, high pressure, and filtration.